Hello everyone, welcome to yourfaculty.com. Today we're going to deal with problems on numbers. So I'm sure you got chance to go through our videos on cyclicity and the concepts on numbers. Okay, let's start with our favorite topic, the cyclicity. The question is find the units digit in 7 to the power of 105. So how do we do it? I believe you got chance to go through our cyclicity video. Nevertheless, I'll just quickly explain the cyclicity in the case of 7. We know that 7 to the power of 1 is equal to 7. 7 to the power of 2 is equal to, how do you do it? 7 3s are, 7 7s are 49. 7 to the power of 3. 7 6 are, 7 9s are, I'm really sorry. 7 to the power of 4. 7 3s are 21. 7 to the power of 5. 7. So we see that 7 to the power of 6. 9. We see that after every 4 powers, it starts repeating itself. So the cycle is, there's a cycle after every 4. So if we look at 7 to the power of 105, how do we know where this portion is? So that we can understand the next digit. By dividing 105 by 4. We know that 100 is a multiple of 4. After that 101, 102, 103. And 104 is a multiple of 4. Hence, this particular portion, 7 to the power of 104 is actually equal to 1, which is basically equivalent to this cycle in the cyclicity of 4. So 7 to the power of 105 will basically be this, equal to 7, or this, whatever be it. So the answer is 7. Moving on. Find the unit digit in the product of 3 to the power of 65, 6 to the power of 59 and 7 to the power of 71. Let's try to address each one of them individually first. 3 to the power of 65. So let's look at the powers of 3. 3 to the power of 1 is equal to 3. 3 square is equal to 9. 3 cube is equal to 9 3s are 27. 7. 3 to the power of 4. 7 3s are 21 or 81. In this case, 3 to the power of 5, 3, 6, 9. So we know that after every powers of 4, there is a repetition. What do we do in this case? Is 3 to the power of 65, and if we look at the powers, the multiples of 4, we know that 60 is a multiple of 4. 15 4s are 60. Then we have 64, and then 65. So 64 is equal to 3 to the power of 64, and then this is 3 to the power of 65. So we know that the units digit of 3 to the power of 65 is 3 into, next is 6 to the power of 59. So power of 6, one advantage is 6 to the power of 1 is 6, 6 to the power of 2 is 6, 6 to the power of 3 is 6. So it's always 6. So we can put this as 6 into 7 to the power of 71. Again, we know that from our previous question, 7 basically follows the cyclicity at 4. So 7 to the power of 71. So let's anyway write this. 7 to the power of 1 is equal to 7. 7 to the power of 2 is equal to 9. 7 to the power of 3 is equal to 3. 7 to the power of 4 is equal to 1. So we know that is 7 power 71. And how does a multiple of 4 work? We know 64, 60 is there, then 64, 68, 72. So after 68, 68 gets over here, then it is 7 to the power of 69, 7 to the power of 70, 7 to the power of 71. So I can just equate these three and then come 7 to the power of 72. So in this case, it is 7 to the power of 71. And remember, it is all multiple of 4. The powers are all multiple of 4 because it follows a cyclicity. After every fourth power, the the unit digit start repeating. So that's what you see here, and that's what you see in the case of 7. So 7 to the power of 3 can be equated, the unit place can be equated to 7 to the power of 71, and hence I write here 3. So what do you do here? What does this mean? It just means that the unit digit just has to be multiplied here, and what do you get in this case? 6 3s are 18, so we take 8, 8 3s are 24, so 4 is the unit digit. I repeat, 6 3s are 18, and we only need the unit digit, so 8 3s are 24. 4 is the answer. Moving on. How many of the following numbers are divisible by 132? This is a very interesting question, and a question that can be answered very quickly. If you had already viewed our divisibility video, you would have got some hint on this particular question. Nevertheless, let's look at 132. What is 132? 132 is a multiple of few factors which can then be used to identify this. 132 is actually a multiple of 3, sorry. So if it is a multiple of 3, what do we do? How do we know what is that number? Sorry, it's a multiple of 3, then it's a multiple of 2. If you take a LCM, it will be very easy for you. Let's say you start with 2, 33, 3 and 11. So 132 is basically a multiple of 11 into 3 into, I'll keep this as 4 because I don't want to do it twice. So I'll keep it as 4. So if out of these numbers, if all the numbers